All right, let's talk about something that is everywhere in productivity culture. This idea that to be successful, you absolutely have to wake up before the sun. Today, we're going to dive into the science that shows your internal clock isn't a choice you make, it's a biological fact.
You've heard this a million times, right? It's the battle cry of the 5 a.m. club. It's all over social media, from CEOs to lifestyle gurus, all promising that if you just force yourself out of bed early enough, success is practically guaranteed.
And that's the big question we're asking. What if all that advice isn't just a little unhelpful for some of us? What if it's actively working against our own DNA? Which brings us to our first section, and we're calling it the tyranny of 5 a.m. Because honestly, for a huge chunk of the population, that is exactly what it feels like. A tyranny.
The promise is so tempting, isn't it? Wake up early, meditate, hit the gym, journal, and you'll conquer your day. But for so many people, the reality is just this groggy, painful struggle. It feels less like winning and more like you've already lost the fight with your own body before you've even had coffee. And here's the key. That's not a failure of your willpower. It's a matter of biology.
So let's get into that biology. It turns out whether you're a morning person or a night person isn't just some personality quirk. It's a deeply, deeply ingrained biological trait. And the scientific term for this is your chronotype. Think of it like your body's internal, factory-set clock. It dictates when you naturally want to sleep and when you feel most alert. And the most important part? You don't choose it. It's written into your genetic code.
And the science on this has gotten wildly specific. Researchers have actually been able to zero in on several genes that shape our chronotype, and one of the big ones is a gene called period 3.
So get this. It all comes down to a tiny difference inside that PR3 gene. There's a section of the gene that repeats itself. If you have the version with 5 repeats, you're probably a morning lark. Your internal clock just runs a bit faster. But if you have the version with only 4 repeats, well, your clock runs slower, making you a biological night owl. And this is where it gets kind of mind-blowing. This internal clock, driven by genes like PR3, it isn't just about sleep. It controls the expression of a staggering 80% of all of your genes. I mean, think about that. It affects everything from your metabolism to your mood. It's a huge deal.
Okay, so if being a night owl is a real biological thing, why? Why would it even evolve? To answer that, we have to go way, way back to our earliest ancestors.
I mean, it's a totally fair question, isn't it? If the early bird gets the worm, you'd think evolution would have gotten rid of night owls ages ago, but it didn't. In fact, it seems like nature actively kept them around for a very important reason.
The leading theory for this is called the sentinel hypothesis. Just picture it. You're in a small, vulnerable tribe out on the savannah. Having everyone asleep at the same time would be a death sentence. To survive, the group needed watchmen, sentinels, who were naturally awake at all hours of the night.
And we actually have incredible modern evidence for this. A study looked at the Hadza hunter-gatherers in Tanzania, who live a lifestyle very similar to our ancestors. Researchers monitored their sleep for weeks. And out of 200 hours of observation, the amount of time that every single person in the group was asleep at the same time was just 18 minutes. That's it.
So, think about what that means. This completely flips the script on the lazy night owl. They weren't sleeping in. They were fulfilling a critical life-saving role. While the morning larks were asleep, the night owls were on watch, protecting the entire tribe when it was most vulnerable.
But it's not just about survival. This evolutionary advantage also seems to be linked to some pretty unique cognitive traits. So let's explore what modern science is now discovering about the mind of the night owl.
There's this fascinating idea called the Savannah IQ interaction hypothesis. The core of it is this. For our ancient ancestors, the day ended when the sun went down. So consciously choosing to stay awake and active late into the night was a brand new or evolutionarily novel behavior. And adopting new behaviors like that is often linked with higher general intelligence. And what this leads to is a really interesting split in cognitive styles. Morning larks often do great in highly structured environments, like a traditional school day. They tend to have excellent academic discipline. Night owls, on the other hand, often show real strengths in what's called fluid intelligence. That's the ability to think on your feet, solve new problems, and connect dots that others don't see.
And this isn't just a theory. The research really backs it up. Study after study has shown that night owls tend to score higher on tests of inductive reasoning, the ability to spot patterns. When they're tested at their peak time, which is later in the day, they often outperform larks on memory tasks. Their brains just seem to be wired for that creative, out-of-the-box kind of thinking.
Okay, let's recap. Being a night owl is genetic.
It's evolutionary, and it comes with some unique cognitive strengths. So what happens when our modern 9-to-5 world tries to force an owl to live like a lark? Well, the consequences, they can be pretty severe.
You know that feeling, right? That constant, bone-deep exhaustion from dragging yourself out of bed hours before your body's ready, all because of work or school schedules? Yeah, scientists have a name for that. It's called social jet lag.
And this isn't just about feeling tired. The health risks of chronic social jet lag are no joke. We're talking about a significantly increased risk for things like depression and anxiety. And even more alarmingly, one study found that night owls who were forced onto a morning schedule for years actually suffered a faster rate of long-term cognitive decline.
I think this analogy just perfectly captures the experience. It says, forcing a night owl onto a morning schedule is like driving a car with the parking brake on. You can do it, right? You can floor the gas pedal and make the car move, but you are creating incredible internal friction, causing long-term damage, and you are never, ever going to perform at your peak.